Okay, so hi everyone. In this video we're going to be doing a few things. We're going to be doing inverse trig functions, half-angle identities, double-angle identities, and evaluating trig functions, which is something that I don't think I went through the last video, because I know the last video I made was probably on the unit circle, and also, I did do verifying trig identities and simplifying trig identities, but I didn't really do, inverse trig functions, or evaluating trig functions, excuse me. So we're gonna first do inverse trig functions. So what you learned in algebra. So what you learned in algebra was this, where if you have an inverse, you have y equals 2x plus 3, and you change that into, x equals 2y plus 3, and then you would basically solve for y by subtracting 3 on each side, and you get x minus 3 equals 2y, and then you would divide by 2 to get y equals x minus 3 over 2 as your inverse, which is f inverse of x. So basically, it works kind of the same way in trig. I mean, I don't really think we don't really do this type of stuff in trigonometry, at least I don't think. But, if you want to do like, if you think about the 6 trig functions that you learned earlier, you would have, so for example, if you had y equals sine of theta, or rather, give me a second, if you had, like the book says, if you had x equals sine of y, to get it to inverse, you would have to say y equals sine inverse of x. And it's kind of the same thing that you kind of did, where you switch up the y and the x. You kind of switch it up. You switch it up over here, and then you switch it up over here. So you kind of get one and the other out. And so that's basically how it works. And so one of the things that you have to learn how to do in trigonometry, or pre-calculus or trigonometry, if you want to call it that, is you need to learn how to do. So this part is going to be inverse trig functions. So you would basically, let's say that you had, let's say that you had sine inverse of 1/2. Well, you would ask yourself, what y value gives me what value on the unit circle gives me a y value of 1/2. This is basically what this is asking, is what value on the unit circle gives me a y value of 1/2. and you would basically look at if you remember your unit circle, you know that, and a little memory trick I used to remember the unit circle, at least the first quadrant, you would say pi over 2, pi over 3, pi over 4, pi over 6, 0. So it'd be like 2, 3, 4, 6, 0. And then you would do 0, 1, 1/2, the square root of 3 over 2, and then the square root of 2 over 2, the square root of 2 over 2, and then the square root of 3 over 2, 1/2, and then 1, 0. And so, sine of theta, remember that one thing that you should know is that sine of theta is going to always equal y, and that cosine of theta will always equal x. And so, if you want to look at what like sine inverse of 1/2 is, it's kind of the same thing. Whenever they ask you for a sine inverse, they're going to get, it's basically going to have, you know, it's basically going to have a y value of a trig of one of the trig values here on the unit circle values, of one of the unit circle values inside the parentheses. So you would do sine inverse of 1/2 and that would be, sorry about that, that would be, so you would do sine inverse of 1/2, and it would be pi over 6, and that would be your answer. So basically, you know, that's kind of how it's done. And yeah, like it says here, it's equal to pi over 6. For part B, you would have, so for part B, sine inverse of negative 1/2, that would be like asking for what value, for what y, for what trig value does y equal negative 1/2? Well, if you look at your unit circle, again, you'd know that you'd kind of, you know, so you look at your quadrants, so it's going to be positive, positive, negative, positive, negative, negative, and positive, negative. This is just saying, like, you know, this is just to help you understand what you want for your, you know, how to find your y value, because you want it to be negative, so it's going to be located in quadrant 4. And so for this one, if you look into the interval of negative pi over 2 to pi over 2. So if you look from the interval from negative pi over 2 to pi over 2, for this one, it would be, I think it would be, I would have to look at the way that the sine graph looks in order to, give me 1 second, guys. So, I believe negative pi over 2 is located over here, so it's located like right here. So you would have a sine inverse of negative 1/2. Let's see, you would have it, so you would have it at wherever, so it would definitely be on the 4th quadrant. So, if we look at our unit circle from over here, we know that negative 1/2 is at 11, it's over here at 11 pi over 6. So, if we go back, the answer to this one should be 11, it should be 11 pi over 6, however, it wants it in terms of negative radians. So in negative radians, it would be negative pi over 6 if you look at it. This one's kind of hard. I don't know if I've ever done one of these before. But yeah, let's move on to the next one. So, if you look at, well, if you look at sine inverse of 3/2, this is another weird one. Since it's not, this one, since it's not, we can't use the unit circle, so we cannot use the unit circle to solve this one. So I believe, so it will not be, it's gonna be undefined, because, I mean, we can't really find this value right here. There's no y value. There's no y value for 3/2 on the unit circle, so therefore it's not going to be, it won't be defined at that point. And so this one, for these, if you look at, so let's say we looked at sine inverse of sine of pi over 3. So if you look at, you know, if you have one of these, if you face one of these, you would basically just remember that these two are going to cancel out. Because if you, it's like basically, I'm thinking it's like multiplying by the reciprocal, but it's not really multiplying by the reciprocal in this one. It's basically like canceling out. So if sine inverse and sine come together, they're going to cancel out, and you're just going to be left with pi over 3. Same thing if you were to say like cosine of, so if you were to say something like cosine inverse of cosine of 3 pi over 2, these two would cancel out, so you're just left with 3 pi over 2. And you can do it other ways too, like if you say cosine inverse of whatever this equals, so cosine of 3 pi over 2 is 0, so cosine inverse of 0, it would be 3 pi over